Imagine a tiny moon, barely half the width of our own, drifting silently through the shadowy realm of Saturn's orbit. Its surface, a dazzling white, reflects the faint sunlight in a cold, haunting glow. This is Enceladus, a world of ice, mystery, and unexpected life-giving secrets. Beneath its frozen facade, far from the warmth of the sun, an alien ocean pulses with potential. Water vapor jets erupt violently from fractures near its south pole, sending towering plumes of ice, vapor, and organic molecules streaming out into the vacuum of space. These celestial geysers have become cosmic signposts pointing towards something extraordinary, an ocean world that might harbor life. They whisper a promise, tantalizing scientists and dreamers alike. Within this icy shell could lie answers to one of humanity's oldest questions: are we alone in the universe? But these answers won't come easy. To truly unravel Enceladus's secrets, future missions must drill through its icy crust, piercing the frozen surface to access the hidden sea below, a feat that pushes the boundaries of science, engineering, and human imagination. For decades, Enceladus was just another point of light in Saturn's complex system of moons. Its shimmering surface belied nothing of the dynamic world beneath. Then, in 2005, NASA's Cassini spacecraft changed everything. As it glided past Enceladus, Cassini's instruments detected towering plumes of water vapor and ice erupting from cracks nicknamed tiger stripes. This was the first hint that beneath Enceladus's gleaming ice lay a world alive with geological activity. Flying directly through these plumes, Cassini captured an array of chemical clues: water vapor rich in salts, organic molecules, methane, and tiny silica particles formed only by interaction with hot rock and water. These revelations painted a picture of a hidden, liquid ocean sustained by warmth, challenging assumptions about where life might thrive. Suddenly, a small, cold moon became a beacon of hope in the search for extraterrestrial life. How does a world so far from the sun maintain a subsurface ocean? The answer lies in the complex gravitational dance with Saturn and neighboring moons. Enceladus's interior is squeezed and flexed by powerful tidal forces, generating heat that prevents the ocean beneath the ice shell from freezing solid. Scientists estimate this ocean may be tens of kilometers deep, enveloped by an icy crust several kilometers thick. The detection of silica grains within the plumes is especially intriguing. On Earth, such grains form only when hot water interacts with rock. This suggests hydrothermal vents might lie hidden on Enceladus's ocean floor, creating conditions potentially suitable for life. If these vents exist, they could provide energy and chemical building blocks, nurturing a biosphere of microbial life that could survive in the darkness, independent of sunlight. While the plumes offer a unique opportunity to sample Enceladus's ocean indirectly, scientists remain cautious. The composition of the ejected material is influenced by complex processes occurring in the icy crust, and some vital chemical or biological signatures may be diluted or destroyed before escaping into space. To truly understand the moon's ocean, missions must go beyond flybys and orbital observations. Future landers equipped with advanced drilling systems or melting probes, known as cryobots, could penetrate the icy shell, directly sampling the liquid environment beneath. Such a mission would be the most ambitious ever attempted in planetary exploration, combining robotics, sterilization technology, and autonomous science to explore an alien ocean without human presence. Drilling into Enceladus's ice is an engineering challenge of epic proportions. The probe must survive freezing temperatures, intense radiation, and the unknown hazards lurking beneath the surface. Earth-based tests in polar regions, where scientists drill through kilometers of ice to explore subglacial lakes sealed off for millennia, have provided valuable lessons. Robots developed to melt and bore through ice with precision are being refined for future interplanetary use. The terrain near Enceladus's south pole is rugged, filled with fractures and slopes that complicate lander stability. Communication delays with Earth require the drill to operate autonomously, making real-time decisions based on sensor data and pre-programmed instructions. These challenges push the boundaries of human ingenuity and perseverance. Our own planet offers remarkable analogs to what might exist in Enceladus's ocean. Beneath thick ice sheets in Antarctica lie lakes isolated for millions of years, harboring microbial life thriving in extreme cold and darkness. Deep-sea hydrothermal vents on Earth teem with ecosystems that rely not on sunlight, but on chemical energy. If Enceladus hosts similar vents, its ocean could be an oasis of life, a silent, hidden world waiting to be discovered. Finding even the smallest microbe beyond Earth would revolutionize biology, confirm that life can arise in diverse environments, and redefine humanity's place in the cosmos. But as we prepare to explore, we face profound ethical dilemmas. Introducing Earth microbes to an alien ocean, even accidentally, could irreversibly alter or destroy native life. Stringent planetary protection protocols guide mission design, emphasizing sterilization and containment. Yet the questions don't end with contamination. If life is discovered, how far should we go in studying it? Should we preserve pristine ecosystems or risk disturbing them for knowledge? These debates remind us that exploration is not just a technical challenge, but a moral journey. The most immediate step toward Enceladus's ocean is a dedicated lander mission. An orbiter would first survey the moon, analyzing plume chemistry in unprecedented detail. Then, a lander equipped with drills, spectrometers, and onboard labs would descend to the icy surface, seeking to pierce its veil. This twofold approach balances safety with ambition, allowing us to prepare for future, more daring missions while gathering critical data. The journey from concept to reality will span decades, requiring international collaboration, innovation, and determination. Looking even further ahead, scientists envision submarines capable of exploring Enceladus's hidden seas, autonomous probes swimming through alien waters, mapping seafloors, and searching for life. Future cryobots might beam data through layers of ice, communicating with orbiters and Earth. Technologies developed for deep-sea and polar exploration on Earth will be repurposed for interplanetary science. This grand expedition could open a new chapter in exploration, one not bound by terrestrial frontiers, but by the very limits of human curiosity. Enceladus invites us to look beyond our small world, to imagine life in places once thought impossible. Drilling into its ice is more than a scientific quest. It is a journey into the unknown, a search for kinship among the stars. If we find life beneath that frozen crust, it will teach us about resilience, about the universality of biology, and about the infinite possibilities of the cosmos. In that moment, Enceladus will no longer be just a moon. It will be a mirror reflecting our deepest hopes and fears. In the shimmering plumes of Enceladus lies a story yet untold, a chapter waiting to be written. The path ahead is difficult and uncertain, but the rewards are beyond measure. Subscribe for more cosmic explorations and stories from the edge of human knowledge. Because the greatest discoveries are often hidden beneath the surface, waiting for us to reach out and uncover them.